I think we have the setup ready. So we have one reactor where we are going to perform the reaction, and then we will take the product out, and then we will filter them using the plate and frame filter. So try to watch this very carefully. Yeah? There are so many tiny details that goes into the whole process. It's not very simple. You have to be very careful when you're going to charge with the different streams. At the moment, what we have is something like a flow sheet. We have some 3 input streams. We have 1 output stream that comes out of your reactor, and then there are few output streams from your plate and frame filter, and then there is 2 input stream in your plate and frame filtration unit. So one is your wash solvent, and another one is something that we take out from the reactor. So at the moment we have only the name, yeah. So there is nothing is flowing inside. So we have to set like how many kilograms of A, how many kilograms of B, and then in the heptane, what will be our volumetric flow rate, and is there any setup time, what will be the reaction time in our reactor, and so do here. In filtration unit, we should know what will be the filtration time and so on. So we are going to do that right now. So at the moment we just named something is heptane, something is A, something is B. So we have to feed this component. So to do that, we have to add those components into the program. So go to task, select pure components, and then click register. So this is a very good example. It was designed by the company who owned the software SuperproDesign, and it's extremely good example. It can help to know the basics of SuperproDesign, and it also helps you to perform the different operations. Like we already know where to drag and drop. Like if you go to unit procedures, we have different sections here, and then we know how to connect, we know how to add 3 different inputs, how to take one input and how to connect it with the second one, and how to set the slave and master type relations. So that one we will do now. At the moment, some stream is coming out and some stream is connected with this one, yeah, with the second unit. So you take the output of your first unit, and then this stream will serve as the input for the second unit. In this case, it's a filtration unit. So let's add the components that we need for this process. So register components. So first let's load heptane. Heptane is our solvent. So if you type in this window, you will see heptane. Just double click it. So it will come to the right hand side. And then we have 2 hypothetical materials. One is compound A and one is compound C. So obviously we cannot find them here. So we have to create them. So to create, you have to press this magic wand here, this icon. If you put your mouse button here, it will say add a new component. Just click one time, and then you can say compound A. And then for the moments, let's change the component name. It has the properties of sucrose. Anyway, we will change it soon. So compound A, and then here select the component name is sucrose. Press OK. And then we are going to just double click on compound A. Then it will open a new window where it will allow you to change the physical constants, like your boiling point, your critical properties like temperature, pressure, eccentric factor, compressibility factor, enthalpy of formation, and so on. So we are going to change the molecular weight to some number, 150 grams per gram mole. So this will now it will become like a hypothetical material with the same properties, with critical properties that matches to that of sucrose, but the molecular weight is 150. Yeah? So if you want, we can even add the economics, like what will be the purchasing price, what's the selling price. If it's in waste treatment, then we can even add about this disposal cost and so on. If you want, we can even mention like hazardous at what level of ppm and so on. So these are other details, but for the moment we are just changing the molecular weight. I press OK. and then we're going to create another compound, which is compound B. So click the magic wand, type compound B, press OK. Let it be, leave it to the properties of water, and then just double click on compound B, change the physical molecular weight to 25 grams per gram mole, press OK. I think we have two compounds, so A plus B will react to give our third compound, which is C. So let's add the compound C. Click here. Let's say this is our, if you want we can even change, like say product C. Press OK, leave it to the properties of water, press OK, and just double click on product C, change the physical constant to 175. So watch the first video where I said if you are dealing with stoichiometric reaction, and so if the molecular weight of compound A is 150 and compound B is 25, obviously this one should be 175. If in case if the reaction stoichiometry follows the rule that 1 mole of A reacts with 1 mole of B and give 1 mole of C. So that's a basic chemistry. I think this process is fine, I think. So we already have all the input streams that needs to go into the reactor. So we can press OK with that. And then we just, so at the moment, if you look at here, we have 3 input streams, but nothing is going inside. We just have some lines and some name. So we have to say, we have to define, this is the stream where we are going to pump our heptane. So just double click on that. And then if you see here, there are one compound A, compound B, heptane, and your product C, and then these 3 things will appear by default. Yeah, so we don't have to worry about this nitrogen, oxygen, and water, because we are going to define which compound should flow under each stream. So in the first stream, which is in red color, so we are going to say heptane should flow into the in this stream. So let's double click on that. So just a double click, and then say heptane. Heptane goes into the, so what it just, we added the stream heptane. Heptane will flow into the stream 1. So press OK. At the moment we didn't define what's the flow rate or anything. We will define it later. So just press OK. And then you select here this stream, input compound A. Just double click, and we said the stream which should go into this stream, it should be, sorry, the compound which should go into this stream should be compound A. Press OK. And then we have to pump compound B in this particular stream. So just double click and then add compound B. So pay attention to these little details. Yeah. So last year students, they always get some error at the end, and then if you check the error report, most of the time it will be like they forgot to add the compound in each of the streams. So these are some small mistakes anyone can do. So just a double click compound A in compound A. Sorry, just a heptane goes into this first stream, solvent stream, and in this one compound B goes inside. So everything looks perfect. So we finished the whole process. We set all the input, and then now we have to charge them. Just a right click, or maybe you can even double click. If you double click, it will tell operation sequence for procedure P1 in R101, which is nothing but your vessel, which is here. So we are going to define what's the sequence of operations that we are going to perform, and we should perform in the correct sequence. It should follow exactly how we are going to perform the experiment. Yeah. So the first thing that we will do, we will charge our reactants. Yeah. So let's charge them. Let's begin with charging our heptane. So first operation is going to be charge. So once you load this one, you can double click and change this one. Let's say charge heptane. Charging means it's like a feeding the your reactants into the reactor. Yeah. So this is the word used by the guys who developed this software, SuperproDesign. So they used the word charge heptane, and then we will charge the other two components. So double click again on charge, and then you come to this right side window, just double click here, and you can change the name, charge A. And then again we need to charge compound B, so just double click and charge B. So what I did is like I double click here, and then once we have the name here, you just double click, and then we can change the name as we like. So charge B. So once this process is done, what we are going to do is like we are going to perform some reaction. So in this, either we can crystallize this material. If you are going to perform some crystallization, we have to press this button, crystallize, but we are not going to do that. Just click and delete it. Just go to stoichiometric reaction, just double click. So you have your reaction, and once the reaction is finished, we are going to transfer all the products out, and then we are going to transfer that product to your plate and frame filter. So that the fourth or fifth operation will be transferring out your products, your final product. So if you come to in the list here, somewhere you will find transfer out. So just double click. So what we defined is like, or what we, instead of writing code and lot of programs, this is like you have a nice graphical user interface, and then it allows you to to just drag and drop. In this case, you just need to double click. If you double click, you will get the next operation in the sequence. So just delete it. So this is like you are telling the software what to do. So this is my I have the setup ready. I have a reactor, and I already connected the output stream to the plate and frame filtration unit, and these are the commands that I'm going to give. First, to charge the reactor with the reactants, and then perform the reaction inside the reactor, and then we transfer out our products. It should go to the plate and frame filtration unit. So this is so simple. So I will press OK here. I think this is done. Everything is fine at the moment. And then here, the wash solvent, just double click here, and then we are going to add heptane as our solvent. So just double click our solvent. So we are going to use heptane to wash our cake. Just press OK. So you should be very careful. Yeah, these are tiny details. Imagine if you forgot to add heptane in the stream, then once you finish your calculation, once you finish everything, and if you try to make a mass balance, you will get loads of errors in the bottom of your window. Yeah? And then I think we did everything, and then just go to the plate and frame filtration unit. So here nothing will happen automatically. We have to define what should happen first. Yeah, so just right click, or maybe better double click on the unit, and then again you will see something like here. Yeah? So what we are going to do is like the first step is going to be filtration. We have a cleaning in progress, filter. We don't have to add the filter option. Seems like it's selected automatically by default. It appears here, and then we can add a wash cake. We can wash the cake with our solvent, and then we can click transfer out, then press OK. I think everything is fine at the moment. So we have 2 unit operations, and in each unit operations we are going to perform some operations in sequence. First one, we are going to charge our reactants, and then we are going to perform the reaction, and then we are going to transfer out the products. In the filtration unit, just double click. So we are going to filter them. This will be selected by default, and then we are going to wash the cake, and then we are going to transfer out the product. In this case, the product will be just the filter cake. So press OK. I think everything is fine at the moment, and now we can start to give some values to each of these streams. So just right click on your reactor and then press charge heptane. If you see, we already loaded, so we are going to do one by one. First, we are going to give some number like how many kilograms or how many volumes of heptane or how many kgs of your reactant A and B, and then we have to define the stoichiometry, reaction stoichiometry, and then we will take the product out. So let's begin do one by one, and we can start with charging the heptane. So just click that one. So if you will get this type of window. So what we see here at the moment, nothing is going inside, so we have to charge it with heptane. So just click solvent. So you have to be careful. So we are charging heptane in this stream, solvent in heptane. So you have to select the correct stream here. So here you have few options: solvent, input A, input B. So select the correct solvent here, solvent heptane, and then how much we are going to load. We are going to load 1200 liters, and then we are going to pump at a constant volumetric flow rate of 30 liters per minute. So select the units carefully. So it will take roughly 40 minutes to fill 1200 liters in the reactor, and then we can give some setup time of 5 minutes. I think this should be fine. Then this is completely okay. Here you see some option set by master-slave relationship. We will come back to this later. For the moment, there is nothing to worry about this option, set master-slave relationship. Yeah, so just keep it like this. And then if you press here the next operation, it will automatically take you to the next one. It will guide you one by one. So now what we are going to do is, like, we are going to charge reactant A. So let's charge it. So select the correct stream here, input stream for reactant A, select it, and then we are going to add kilograms. Let me check how much we need to add. So we are going to add 50 kgs. I'm going to add 50 kg. And let's put a setup time of 5 minutes again. And then everything looks fine. Kgs. Volume is I think this looks fine to me. And then process time, we can put 20 minutes. So it takes roughly 20 minutes to load 50 kgs. So we can mention something like that. I forgot to put something before. Let's go back to solvent heptane. Okay, this one. Once we load with heptane, we can give this ratio like 90%. So we will fill 90% of the vessel with our solution. Yeah? So we can even put 65%. especially when you are doing some anaerobic reactor. This is the maximum allowable limit. So for this case, it's 90%. So anaerobic fermentation, that time we will give an maximum allowable percentage of 65 for this reaction. For this hypothetical reaction, we will fix this value to 90%. Press next. Input stream is A. In this stream, we are pumping the compound A, 50 kilograms. Setup time of 5 minutes, and process time of 20 minutes. So you can even change this number, it's not really important. It's just if you want, we can put say 10 minutes to load your 50 kilograms in the reactor. Then press the next. And then we have one more input stream. Just select input B, and then how much mass we need to add. Let's add 40 kilograms. You can even add say 60 kgs. Yeah, there is no rule like that. But let's put setup time of 5 minutes and say let's we are going to load this say for 30 or 40 minutes. Let's put 20 minutes. Yeah. So whatever the time which you are giving now, like setup time of 5 minutes, process time of 20 minutes, everything you will see this at the end of your, once you finish the entire flow sheet, once we solve the mass balance, we will generate Gantt chart. There you will see these values appearing like, okay, you start your experiment time t equal to 0 minute. So you take this many number of minutes to charge all of your reactants and so on. So, okay, maybe let's put this for 60 minutes. You will see that in your Gantt chart, the difference. So 60 minutes. Everything looks fine. Go back. Vent emissions. Yeah, if you remember, we have some vent gas here. So in that one, we have to select heptane. Venting using vent gas, only heptane. So press OK. Think it should be fine now. We charged already with heptane. We charged already with input A. So if we added the stream, this one will turn into these 3 different colors. And then we already charged with input B in this third stream. And that's the mass of B that we are going to load into the reactor. Press next. So what will be the next operation? So we are going to perform the entire reaction at 50 degrees centigrade. And then, so to heat the temperature from room temperature to 50 degrees centigrade, we need some hot gas. In this case, we are going to use some steam. So just steam. So remember, in your assignment, some of you will have crystallization or something similar where you need to cool your solution. Then in that case, instead of steam, you have to select something like a freon or maybe chilled water or cooling water. So it depends on what temperature you need to, what will be your reaction temperature. If you're going to perform your reaction temperature at 0 degrees centigrade, then you can select chilled water. If you're going to go to some cryogenic temperature, then you have to select freon or other cooling agents. So keep this in your mind. So that's our reaction temperature. Volume is fine. Fed batch. Okay. So now we have to define the reaction. So we are going to perform a stoichiometric reaction. So click reaction and then press this conical flask button. So this is our stoichiometric reaction. So we should have some reactants on the reactant side, and we should have some products on the product side. So on the reactant side, we have to add compound A, compound B. So these two are our reactants, and then our product here, C is our product. So what we defined is like 1 mole of A and 1 mole of B, they combine to form 1 mole of our product, which is C. So since the stoichiometric ratio is like 1:1 to 1 mole of product, if you look at the molecular weight, it should match, 150, 125, the sum should be equal to here, 175. Just press OK. I think this is fine. Now I think we have to, okay, conversion, this is really important. So for the moment we assume 90% of your reactants are converted into products. So let's put 90% conversion, and then everything looks fine. Press next. So this is your final operation. So transfer out. So we need to take the product out. So where the product should go, in which stream it should go. So we should select output from the reactor. So if you want, we can call this something like a pipeline. So we have to select output, this reactor, and then it's asking whether we need to remove all the contents in the reactor. Almost, I think this is practically impossible. So let's put 95%. This is a reasonable assumption. And then I think this looks fine to me. And then this is really important. As I said to you, like whatever the product that comes out, it goes to the second unit. So there should be some relationship between, so what it says is like your reactor will be the master, and this guy filtration unit will be the slave. So he dictates when to start the second unit. So if the reaction time is 8 hours, then the second unit we will start at the end of the 8th hour. Yeah? So if the reaction time is only 6 hours, so we will start at the end of your chemical reaction. So if you start the process, say like 0th minute, and it takes say like 6 hours plus almost 1 hour to charge your reactants and so on, and plus additional 15 minutes of setup time and so on. So only after then we can start the next unit operation. So that's the meaning of this. So we are going to set some master-slave relationship. Just we are going to tell to the program that, okay, whatever the product that comes out, it's going to some other unit. Yeah. So set by master-slave. Then click setup. So what is this? So who is the master procedure? Your plate and frame, and match a single unit operation. So what it says is like the transfer out is going to to your plate and frame filtration unit, and in the plate and frame filtration unit we are going to perform different operations. One is like filtering the solution, and then we are going to wash the solution, and then we are also going to transfer out the cake. So what we defined is like so this guy will be the master, and we are going to transfer this product to your second unit. In this case is plate and frame filter, and once it entered, the first operation that we are going to perform is filtration. So we cannot select the other thing like cake wash or transfer out. You must select the filtration. We are going to filter whatever that comes out. We are going to filter them. So I think everything is set. Just press OK. I think this is fine. Just press OK. This should be fine, I think. And now come to the second unit operation or unit procedure. Just click operation data, filter. So we are going to filter. So what we are going to filter, we have so many compounds here, compound A, compound B, and then our solvent and our product. So we are going to filter only this compound, product C, and we are going to assume compound A and B are soluble in heptane. So it will come with filtrate. So we are going to remove product C, and then I already explained what's meant by loss on drying. So let's put 30%, will something like a loss on drying, and then what else is here? Setup time. Let's put a filtration time of 3 hours. 3 hours. 3 hours. So keep filtration mode. Input from the filtrate stream. We have to select the correct stream here. Okay, it selected automatically the correct one. It should be filtrate here. This is correct. And then we can put a setup time of 5 minutes. Filtration time is we set 6 hours or maybe 3 hours. I think everything is fine. Just press next. Components marked as must have a non-zero removal percentage. Percentage removed. Let's assume we are going to remove 95% of all the products. So let's put 95. Press next. Wash in stream. So this will be your washing solvent. So just click here. So this is your wash solvent, and then you already charged with heptane. Yes, everything looks fine. And then where we collect the wash liquid, it should be wash liquid. Everything looks fine. Let's press next. We can set a washing time of 30 minutes. This is okay. And then the final operation is we need to take the product out. So transfer out will be connected to the stream where we renamed it as cake. Let's assume we transferred 100% of the filtered cake. This is okay. Setup time 15 minutes is okay. Process time, let's put 30 minutes. Press, I think we set everything clean, I think. Press OK. So I think everything is finished. So we already charged, we added 2 unit procedures, and then we added input streams, we added the output streams, and we connected both of these streams using this one pipeline. I renamed it as output from the reactor, and then we are going to wash the cake using heptane, and then we take the wash liquid out as one separate stream, and then we are going to take the filtrate out, and then we will collect our product, which is cake. So this is our product that we are interested in. So if we did everything correct, if we added our component under each stream and without any mistake, if you click here, so you don't have to worry. Like, we know some mass is going in, some mass is going in, some mass is going in, some mass comes out, and again some mass of solvent goes in here, and then some filtrate comes out here, and then some cake comes out here. So there will be some kg of heptane, kg of A, kg of B, and some kg of your product, which is coming here, C, plus some of your solvent, and then some kgs of filtrate, some kg of your final product, and then some kg of your wash liquid. So everything will be here. But if we need to do the calculations by ourselves, it will take a lot of time. Yeah? But we already gave the stoichiometry. So 1 mole of A to give rise to 1 mole of B, and we already set some reaction conditions like 90% conversion. So which means whatever we load here, 90% of them will be converted into products. The software will calculate everything by itself, and then it will perform the mass balance calculations for you. So if you click this one, you shouldn't get any error in the bottom, and then you will see some message: perform mass and energy balance has ended successfully. Yeah? If you have some error, then you have to write me an email or take a snapshot of the error and tell to me this is the error I have. I will fix it. So I think at the moment everything goes fine. So if we want to know the amount of cake, mass of cake, we can check that by, what is that option here? I think edit labels. No, not this one. This is fine. Compound A. Just right click. There is a way to add the tag. I couldn't see it here. I think it's somewhere here. Edit style. Yes, and then you can press info tag. Info tag. I think this should be fine. Yes, I think that's the mass that we have. So our product will be 67.86 kg per batch. So this one will change if we change the percentage conversion in the reactor. Yeah, say like operation data, go to react, say the percentage conversion here. Say just put 60% for example. And then perform the mass balance calculation again. And you see the number here, it changed, 45 kg per batch. So this is very easy. So if you know the percentage conversion and if you know the reaction stoichiometry, so SuperproDesign software makes your life really easy. But that's why industries are considering this one as a big skill set. Yeah. So if you know SuperproDesign software, it's a very big plus, especially if you're applying for any job in pharma companies. If you imagine if you change, for example, if you just right click, go to just a double click here, you already charged A and everything. Say charge A, let's put 100 kg for example. Press OK. Okay. And then charge. And then if you perform a mass balance calculation, you see here the product mass changes. So this is something like 89.292 kilograms per batch. So this is a batch operation that we are performing. So at the end of our reaction time, so this is the amount of mass that we are going to produce. Yeah. So you should be very careful what you are going to enter. So drag and drop is very easy job. Like you go to say like unit procedure, say like centrifugation. Maybe you can even put some ion, like how do you call this, activated carbon adsorption unit. Just put it here. So it's very easy to drag and drop, connect the pieces, add some input information like how much mass goes inside, how much mass comes out. But you should know what type of reaction that you are dealing with. You should know the reaction stoichiometry. You should know to make some reasonable assumptions for setup time, process time, and so on. And you should know the percentage conversion, and you should know the working temperature, and you should know what type of stream that you are using to heat or cool. So those things you should take attention. So imagine if I right click here, go to reaction, if you go to the, say for example, set the final temperature to 0, then we have to put some agent to cool. So let's put cooling water. So inlet temperature will be, no, it will set the final temperature to 0 degrees centigrade. Just press OK and just perform the mass balance calculations. Yeah. So you have to know what you are doing. Yeah. Okay, the target cannot be, okay, this is the one I said to you. If you did some mistake, then it will show you some error. The target temperature cannot be achieved with selected cooling agent. So cooling water can be used only if you need to maintain temperature of 25 to 30 degrees centigrade. So just it will guide you so what to do. So just right click, go to operation data, click react, and then change it to maybe freon or maybe chilled water. Let's see, chilled water, it can go from 5 degrees to 10 degrees. Freon -4 to -3. Okay, let's select this and see what happens. Press OK. Okay, still we have that error, so we have to change the cooling agent. I never tried this before. Probably glycol is good, I think. Just select glycol, press OK, and then if you perform with the selected cooling agent, the agent's exit temperature is too high. Why is that? Okay, yeah, once you put freon, everything looks fine. So this is something you have to pay attention. I think some of you might get some project where you might need to cool the reactor temperature. So pay attention which type of cooling agent you are going to use. So anyway, it's not difficult. You can play with the information here. Yeah. So once you select here, it's giving some guidelines here. Tn should be 25 degrees. So that's the maximum that we can maintain with cooling water. So just select freon and press OK. You perform the mass balance calculation. I think it should be fine. Yeah. So at the end, once you finished with everything, you have to generate some Gantt chart. So click reports, and then let's create a chart first. Let's create Gantt chart. Let's create operational Gantt chart. So what it says, something is not correct in this one. So this is your 0th minute. So this is your charging time of your heptane, charging time of your A, which is here, 0.25 hours. It takes 40 hours to charge heptane, and then 1 hour to charge B, and then to reaction time is 1 hour, and then it takes 3 hours to take our products out. And your filtration process, it should start. So this is your first major unit operation, the blue one, and then this is your second one. Normally it should start from here, but for some reason it starts from here. I think we did some mistake. I can close this one and try to check what's the problem. Transfer out. Already set this one, scheduling. This is So something I'm not happy, like I will show you again what I'm checking at the moment. If you click the Gantt chart here, okay, let's solve. Okay, so what I see here is like, so you see the blue line here, just follow my cursor. So this is for your unit operation. You are performing some reaction and it's taking roughly 48 hours. I think we should change, we can change these numbers. And then if you look, like your reaction starts at 0th minute and your filtration process, it also starts at 0th minute. This is not true because we need to start the filtration unit only at the end of all the operations performed in this particular unit operation, which is just a chemical reaction. Yeah? So there is something is not correct. So that's what I think I forgot to miss something. Sorry, I missed something when I was setting up the flow sheet. Let's close this. It should be somewhere. Filtration unit. Go to scheduling. Okay, it's here. So if you look here, so let's go back here. So this is what we are doing in this reactor. In the plate and frame filtration is like we are going to filter the product. So just to select here filter, and if you go to scheduling, it says like the filtration starts at 0th minute or 0th hour. Yeah, so but this is not true. So we have to start this unit operation or unit procedure only something related to the time associated with the unit operation 1. So it should be relative to another operation in another procedure. So our starting time depends on the reaction time involved in the unit procedure 1. So let's select R101, which is nothing but your reactor. And then at the end of the transfer out operation, so once you start to transfer out your products, we will start our filtration unit. So I think this should be fine. Just press OK. Press one more time the mass and energy balance. We don't have any error. And if you go to generate the Gantt chart now, probably it's fixed. Yeah, I think this is what we want to see. So if you see here, so once the transfer out started, your filtration unit started automatically. Yeah. So this is what we want to see. So now we can get some overall idea, like it takes 48 hours to finish roughly. This is not correct. I think we did some mistake. Let's click here, unit procedure, charge heptane, 1200 liters, setup time, volumetric flow rate. Oh, this is wrong. Let's put 30 liters. I mentioned 30 liters per minute. Yeah, this should be fine. Press next. 10 minutes, 5 minutes, everything looks okay. Now we press mass and energy balance, and if you create the chart again, this looks reasonable. Yeah, so you finish the batch process. We manufacture the product C roughly in 8 and then plus few more hours, so it's good. And so reaction happens for 1 hour, charging of B happens for 1 hour, charging of A, it takes 0.25 hours, and you manage to charge 1200 liters of heptane in 0.75 hours. So whenever we talk about a batch process, normally in the textbook we see like, okay, we have A plus B giving rise to product C, that's my kinetic constant, tell me what's the order of the reaction. Probably you might be used to those type of things, but in engineering, time really matters. Yeah, so we need to know how many minutes we spend on each and every operation that we perform on any unit procedure. Yeah, it can be filtration, drying, or evaporation process, or other unit procedure like crystallization, adsorption, or anything. Yeah, or ion exchange, for example. We should know the time, like what's the setup time, what's the process time, how many minutes we need to charge your to charge your solvent, how many minutes you need to load your other reactants. So everything matters. Yeah, so this is the Gantt chart that we developed so far. So it gives some nice information, like at the end of 0.75 plus 0.25 plus 1.08, so whatever the time, at the time we start both, we are going to take the product out, and we simultaneously we switched on our filtration unit. Yeah, so we are going to filter the product for roughly for 3 hours, and then we will wash the cake for another 0.5 hours, and then we will transfer out. It will take some other time, 0.75 hours. So this is the Gantt chart. So in your report, in your, you have to develop, you have to generate this type of Gantt chart, and then you have to make a statement out of that, like, so in total this is the time I need to perform this particular, my first unit of procedure, and then another few many hours for the second unit procedure, and then you have to explain it clearly in your assignment based on your Gantt chart. You can keep this one here, and then we can create one more chart. So let's put multiple batches. So if you look at here, if you put multiple batches, it will tell the entire time for the complete recipe. So if you click this plus symbol, it will give you some perfect information, like 7.42 hours. This is for that entire process time. Like it involves you charge your reactants, charge your solvent, take the transfer out your product, filter them, wash the product, and then take the product out. So all these operations, it takes 7.42 hours, and then we spent roughly 6.17 hour in the unit operation 1, and then 4.33 hours. It starts somewhere here. So if you look at here, plate and frame filtration unit, we started somewhere in between. So this is the point when you started the transfer out operation, when you start to perform the transfer out operation in your first unit procedure. So that's the meaning of these charts. Yeah, and it also gives some very good idea, like so what you look here, this exactly at this point. So we are still continuing to we are going to filter, and then we are going to perform some operation like washing the filter and then transferring out the cake. But in the meantime, if you finish once you finished with this transfer out operation, so your reactor will be clean. So at this stage, you can start your reactor. You can load with fresh solvent and fresh reactant, and then you can start to perform the second batch process. So which means we can effectively use, so something is going on with the filtration, but once you finished with all the operations in the first unit procedure, you can straight away start with the second batch, so that you can produce more new products using that reactor. So that's the meaning of this type of chart. So in your report, you have to include your Gantt chart, and then you have to include this chart, operation Gantt chart for multiple batches. So close this one. Let's close this one. And then there are few ways to get some report material, and did not finish normally. We didn't add any information about the cost of our reactants or products. Let's save this file. I'm going to call example 1. So it's generating something. Let's wait. I don't know where is the document. Okay, it's here. It generated the file here. So batch sheet number, product is example 1, whatever. So this is our reactor. This is our charging time of A, charging time of B, the time involved. It starts at 1 hour, finish at 2.08 hours, and so on. So you have to attach this sheet. You have to generate this sheet, and then you have to attach in your final report. So in your final report, you should have this, we call them as a batch sheet. So generate this one, batch sheet number, just put 1 or something like that, and then product, write your product name, whatever we are going to produce, and then you create everything here. Yeah, so attach this one together with your report. So convert everything into one single PDF file. Let's save this one. I think everything looks fine to me. And then in your report, just add all the details here, like edit. So go to style, edit style, and then info tag, press OK. So also do the same for all the input stream. Info tag, and then info tag. So, and then you can also check it here as well. So how much mass comes out? 928.67 kilogram of batch. So what is that? So this includes your product C, which is here, and then it also includes some of your solvent. So if you want, we can check the filtrate mass. Right click, edit labels, style, edit style, info tag. So 883, you see this will be your solvent plus maybe some of your reactants inside. And then you can also check the wash liquid. Style, edit style, 206.16. So this number will change if you change this value. Let's put filtration. If you put loss on drying, say like 60%, you see this value will automatically change. Cannot fit the equipment. Okay, yeah, it's wrong. You see this value will automatically change. Yeah? So this value changes depends on loss on drying, which means if the loss on drying is less, this value will decrease. Yeah? So if the loss on drying is higher, this value will increase. So I think I did everything well so far. Explained everything. So what I'm going to do is, like, you are going to watch, try to repeat the same example, and then I just want to know whether all of you did this the exercise or not. So together with your report, just try to play with these numbers. It don't have to be like a 100, like 40 kg in or 50 kg of B in. You can change the number, you can change the reaction time, you can change even the stoichiometry, and try to generate a new report, and then put your name, attach it, and then make it and then append with your final report. I just want to know all the students in each group, they solved this particular example problem, and then the remaining you can work in group. Yeah, so I think you know how to add the unit procedure, how to add input stream, and then how to perform different operations under under each unit procedure, and then how to connect, like if something is connected with the second unit, you know how to set the master slave relationship. So I think that's enough. And you also learned how to generate a different type of Gantt chart. So you have to make everything, you have to include everything in your final report and then send it to me. I think I'm going to stop recording now. Thanks for listening.